Our last section covers question number 6. The paragraph leading into number 6, our intro, says a scatter plot and a line of best fit, the most accurate trend line, can be created using a graphing calculator, a spreadsheet program, or other computer algebra systems, or CAS. Linear regressions is a model used to find the line of best fit. A line found using linear regression is more accurate than a trend line that has been visually estimated. You can perform linear regression using a graphing calculator. Number 6, enter the book passing data you collected in item number 2 in lesson 13.1 into your graphing calculator. Enter the number of students as X values and the corresponding times to pass the book as Y values. All right, so we're going to be looking back at the data we collected on Friday, or that was technically given to us on Friday. Nope, sorry, Thursday of last week. Let me pull that data. That data is this set right here. I want you to grab out your calculator and I want you to, I've cleared my calculator of everything that was on it. And I'm on the home screen, okay? Let's take a look at this. I'm going to show you how to input data in our calculator. We're going to go to Stat. We're going to go to Option 1, which is Edit. And see how it's got data in there? We need to clear the data out. So you need to go up to where it says L1, and I want the black box to be there on top of L1. And I want you to press Clear, Enter, and it should clear out the entire list for you. We're going to do the same thing with L2. I go over to where it says L2 at the top. I press Clear, Enter, and it clears out everything in the list. Now I want to input this data. So I'm going to go back over to L1, and it says input the number of students as your X. Well, L1 is going to be my X column. So I'm going to type in 3, 6. Now I'm pressing these numbers and pressing enter so it goes down from one line to the next. So 3, 6, we're going to do 9, 11, 13, and 15. So I got 6 points of data. 1, 2, 3, 4, 5, 6. 6 points in my thing. I'm going to skip this up a little bit so you can see the entire calculator. Now you can't really see the screen. Okay, so I got to go back a little bit down. There we go. All right, so now we're going to input our L2 data, our Y values. So I'm going to type in 4, enter, 9, enter, 11, enter. Make sure that you're entering them in the order that they were given to us. 14, 17, and 19. You want to make sure that our X matches with our Y each time. Okay? Now what we're going to do is we are going to press second mode to get back to our main screen. So I've input my data. That was the first step, okay? It says to find the equation of the line of best fit, use the linear regression feature of your calculator. So I'm going to make a note of what we've done thus far. We went Stat. We went to Edit. Then we cleared L1 and L2. Then we entered L1 and L2 data. Now we're on to a next step. I remember I did press second mode, and this got me back to the main screen. Anytime you want to go to back to the home screen, you just press second mode and it gets you back to this main page where nothing's on it. Okay. Now what we're going to do is we are going to go to Stat, over to Calculate. So I did Stat. We're going to go to Calculate. And we're doing a linear regression. So I'm going to go down to Lin Reg. And we're going to do the AX plus B model. It's going to ask us what our X list and our Y list is. It usually goes back to L1, L2 as a default. So if you always store your data in the L1 and L2 column, that's what its default is. So we're going to go, we need to check to make sure L1 is X and L2 is for Y. Okay. And that's what it says. So I'm going to go down and press calculate. It should give me back some data. It gives me back an A value and a B value. It says the calculator should return values for A and B. Write those values below. All right, well, we have 1.226130653 for A. And my B is going to be 0.685092127 and 3. Ooh, that's a lot. The value of A is the slope of the line of best fit. And 0, B is the y-intercept. Round A and B to the nearest hundredth and write the equation of the line of best fit in the form y equals ax plus b. Describe how this equation is different from or similar to your equation in item 8 that we wrote. Okay, well, A is, we're going to say that this is approximately 1.23, and this is approximately 0.69. Because remember, this is my tenth hundredths. So y equals 1.23x plus 0.69. And it says compare this to our item 8 answer. Let me go back to our data from the other day. This was our data from the other day, from Thursday of last week. This was my equation. Y minus 11 equals 7 over 6, x minus 9. Well, one, I can tell clearly right off the bat, it's different because of the form. So the forms are different. Well, let's try to make this one into our y equals mx plus b form, our slope-intercept form, and see if there's anything else that helps us here. I'm going to write this up at the top of this page over here. I'm going to do y minus 11 equals 7 over 6 x minus 9 and see what we come up with, okay? First thing I'm going to do is I'm going to use the distributive property. So I got y minus 11 equals 7 over 6x minus, that would have been 63 over 6, because 7 times 9, and we're going to divide by 6, gives me minus 10.5, okay? Next, we're going to add 11 to both sides. Y equals, well, let's go 7 over 6 is 1.17 if I round to the hundredths place, like they asked us to do here. And negative 10.5 plus 11 is plus 0.5. My slope from the one we did the other day was 1.17. Their slope is 1.23. Are those close or really far apart? Slopes are close to the same. Let's talk about our y-intercepts. Their y-intercept was 0.69. Ours was 0.5. Again, very close. So our y-intercepts are close to the same. Now, remember when we did our trend line the other day? I did that based on just visual effects. The calculator is doing a whole lot of computations that we can't even imagine behind the scenes to get the numbers that they came up with. So our numbers are going to be somewhat close, but not exact. And that's understandable. That is understandable. On to our final debriefing question.